Hydrocarbons are compounds that contain only carbon and hydrogen. Hydrocarbons can be aliphatic, as in straight or branched chain, or aromatic, which contain one or more benzene rings. We'll focus on a particular family of carbohydrates known as alkanes. These are described as saturated hydrocarbons because they possess only single carbon-carbon bonds and cannot incorporate more atoms into their structure. Because there are a vast number of carbon-based compounds, a systematic method for naming these is needed. Originally, chemists named newly discovered carbon compounds in a weird, arbitrary way. Check these examples out, but they give little to no indication of the chemical structure of the compound. This is a mess. When naming a hydrocarbon, or any organic compound, attention must be given to two characteristics of the compound. Number 1, these are the number of carbon atoms in the hydrocarbon chain, and 2, the presence of any functional group in the compound. The number of carbons in a hydrocarbon chain determines the stem name of the compound. The functional group, which are specific substituents, determines the suffix added to the stem. Alkanes possess only single carbon-carbon bonds and do not contain a functional group in the usual sense of the term. Their family name is indicated by the suffix -ane. The simplest member of the family is called methane. The stem name meth, indicating one carbon, and the suffix -ane, the family name. Similarly, the two-carbon compound of this family, with the stem name eth and the suffix -ane, is called ethane, and so on and so on. Notice how each family in the alkane homologous series differs from a single CH2 from its nearest neighbour. Consequently, the general formula for alkanes can be written like so, where the letter N is in any integer. For example, butane has 4 carbons, so its formula would be C4H10. N is the number of carbon. It's important to recognise the longest straight chain alkane is quite obvious with the examples. However, here are loads of alkanes which contain branches. These make this more challenging. So let's look at a branch chain alkane. In this example, the longest continuous chain of carbon is this. Yep, it doesn't have to be straight, so we know the suffix will be hexane. We also have all these branches, or substituents. And if these are a carbon group, then we call it an alkyl group. For example, these look like methane minus a hydrogen, so we call them methyl. If it resembles ethane minus a hydrogen, then it's called ethyl, and so on. Number the carbons so that the branches have the lowest possible number. So if we go from here to here, the 2 methyls are located on the 3rd, one on the 4th, and one on the 5th carbon. If we numbered the parent chain in this direction, there is a methyl on the 2nd, 3rd, and 2 on the 4th carbon. This results in a much smaller number where the sum of the positions are calculated, so we name it in this direction. These branches are written in alphabetical order. In our example, we only have one type of branch, but if there was an ethyl group, it would be written first. So, allocate the position of your branches. In this case, it would be 2, 3, 4, 4. Add a hyphen to separate numbers from words. Add the prefix tetra because there are 4 methyl groups, and then finish it off with methyl hexane. It's worth noting that prefixes do not affect the alphabetical naming. More examples will be done on another video.